Tomorrow in class we are going to go over the rest of this note packet over chapters 1 and 2, but what we're going to knock out this evening is the very end of the notes that addresses scientific notation, or what you may know as exponential notation. Scientific notation is a way to deal with really big or really small numbers. And we in science use them a lot because we do measure very large things and very small things. But you may also use them in your math class and should have been taught this before in one of your math classes. In scientific notation, remember that the number consists of the coefficient, which is the large number in front, and some kind of power of 10. And so if you have a positive power of 10, it is a big number, and a negative power of 10 is a small number. And just to make sure that you guys know what I'm talking about, like if I had a number like 5.22 times 10 to the negative third, the coefficient is this business over here, and then you have your exponent, okay, or your power of 10, which is this number here. And since this is negative, we know that this is actually going to be a tiny number. This set of examples has you take numbers in regular notation or ordinary notation and put them into scientific notation. So how you go about doing that is that your numbers have a decimal in them, and if you don't see the printed decimal, you should know where the decimal occurs, which would be at the end of the number. And then what we do is we move that decimal behind the first non-zero integer, which means the first integer that's not zero. So in this particular problem here, we have our decimal right here at the end, and sorry, I don't really have very good skills working the stylus here, but there's my decimal at the end. I would take that decimal and scooch it over 1, 2, 3, 4, 5, 6, 7 places to right between the 1 and the 2. And so I'm going to end up with the number 1.2, and then I have to figure out my exponent. Now, because this is a large number, what is this? 12 million. I know that my exponent is going to be positive. And since I moved the decimal over 7 places, then my exponent is going to be 7. Let's go ahead and try that with the next example. So the next example, again, the decimal would appear at the end of the number since there's no printed decimal. And I am going to move that over to the first, or right behind the first non-zero integer, which is that 8. So I'm going to move it over 1, 2, 3, 4, 1, 2, 3, 4 spots. And when I do that, I get 8.513. And yes, do keep all those numbers. And I moved it over 4 spots. So times 10 to the 4th. So at this point, I'd like you to go ahead and pause the recording and try the next 3 examples, and then I'll share the answers with you. So you need to pause it now. Do it. Okay, so on the next problem, you took this decimal and you scooch it over 1, 2, 3, 4 this direction. So this will be 5 times 10 to the negative 4th. This one you scooched over 1, 2, 3.42 times 10 to the negative 2nd. And this last example I just put up there to really mess with you, not going to lie. So I don't really have to move the decimal anywhere, but how would you put that in scientific notation? Times 10 to the... We don't want it times 10, that would be 21. So let's say times 10 to the 0. That would do the trick. And so there's all the answers nice and typewritten so you can actually see them. Alright, let's go to the next slide. So for the next slide, what we're going to do is be taking numbers that are already in scientific notation and putting them back to decimal form. So it's just a matter of knowing which direction you need to go with that exponent. Remember, if the exponent is positive, the number was really big, and so we would move the decimal to the right. So like on this first one, this is positive, so we're going to go to the right. But an example like one of these ones here with a negative exponent, you are going to be moving the decimal to the left. And so we'll go ahead and try the first one together. And so the first one, we're moving the decimal to the right, and we are going to move it 5 places. So that would be 1 place, 2 places, 3, 4, 5. And it would look just like that. So what I want you to do is pause it again and go ahead and try the next 3, and then I will show you the answers to those. So make sure you're pausing it now. Okay, so hopefully you've tried the next 3. So the next 3, the next one, we're going to be scooching the decimal 2 places to the right. And so that would just give us 244. The next one, we are going to move the decimal 3 places to the left. Now I'm assuming that you know this, but you do know that that decimal is right there. So we're going to move it past the 5 and then a couple more places. Alright, so that's going to give us 0.005. And I do like you guys to put in that 0 in front right here. 0.005, not 0.005. That's actually a medical thing to do. They insist that you have that decimal in front. And the reason is that way when they are doing medications, that they don't get the wrong dosage, just in case some little person there who's ever reading the doctor's handwriting can't figure out that that is actually a decimal there. So please do put the zeros in front. And then the last answer, if you move the decimal place over to the left, you get 0.0702. Okay, the next thing we're going to look at is correcting incorrect scientific notation, and this is a little bit stranger of an activity. Your calculator is not going to give you incorrect scientific notation, you know, something like 12 times 10 to the 8th. But it does come up, particularly on the multiple choice portion of the AP test, if any of you decide to take AP Chemistry, that you're having to do scientific notation without a calculator, and so that it does happen. One of the things to keep in mind, and I should have put this on the slide, but you can write this down, is something called the bigger, smaller rule. The bigger, smaller rule, which really doesn't mean anything, but if you look at it, what it's supposed to do is to help you remember what to do with the coefficients and then the exponent. And so like this number here, you have a 12. 12 is no good. You really want it to be 1.2, okay, which is smaller. Okay, so if we're going to make that number smaller, we're going to have to make the exponent bigger. Okay, so how many decimal places are we moving this? The coefficient. Well, we're moving it 1. So we're making this 1 decimal place smaller. So that means we need to make the exponent 1 decimal place bigger, which would be 9. Alrighty, let's go ahead and try the next one together. And so we have the number 0.85, and we really want it to be 8.5. 8.5. So we're making this number bigger, which means that we need to make the exponent smaller by however many decimal places we moved. And since we only moved 1, it means we moved this smaller by 1. The next one is a negative number, and negative numbers do cause some trouble. But you do have to just think number line on what's bigger and smaller. Like for instance on -7 here that we have. What's 1 bigger than -7? Well, that means going more positive, which means that 1 bigger than -7 is -6. And 1 smaller than -7 is -8. So here we're going to make this number bigger by 2 decimal places. So bigger, which means we need to make the exponent smaller by 2 decimal places. So that's going to be -9. So go ahead and pause this and try the very last one for yourself, and we'll check the answers in a second. Okay, hopefully you had enough time to do that. So on this one here, we're making the coefficient smaller by 2, which means we need to make the exponent bigger by 2. And so hopefully you got this answer, 3.4 times 10 to the -1. So this next slide is your friendly reminder on how to operate your calculator. Remember to use the trick that I told you last time by using that whole times 10 to the button. which on your calculators is that EE button. For those of you with TI-84s, remember it's behind the comma. It's a second function behind the comma, and the comma is above the 7. And so make sure you use that EE button. When you do use that times 10 to the button, make sure that you don't actually press times before times 10 to the. It does throw your answers off by a power of 10, so do not do that. Also, you shouldn't have to use this little caret thing to raise your power. Also, you do not need to use parentheses. In fact, it makes the math very difficult if you don't use your times 10 to the button. And let me see if I can find an illustration to show you how. Okay, this will work as an example. On this problem here, I want to do 5 times 10 to the negative third divided by 6 times 10 to the negative fifth. If you put it in your calculator as follows, you do 5 times 10 caret negative 3 divided by 6 times 10 caret negative 5. You actually do have a problem and you will get the wrong answer. The reason you will get a wrong answer has to do with right in here. When you say times, it's thinking that you actually want to multiply all this stuff times this 5 over here. Okay, so you could fix that problem by doing parentheses 5 times 10 caret negative 3 parentheses slash parentheses 6 times 10 caret negative fifth parentheses. So you could do it that way, or you could do it the way I showed you in class, which is 5 EE negative 3 divided by 6 EE negative 5. Okay, so when you do it that way, when you use that times 10 to the button, it treats that number as all one number. When you do it this way, up here, it thinks you're really wanting to do math. And you're not wanting to do math, you're really just wanting to put a number into a calculator. So hopefully that explains it a little bit. If you need a little bit more explanation, you can talk to me about it in class. So the very last thing we're going to look at is a practice problem which utilizes your calculator skills. Can you actually get this problem in your calculator correctly? So what I'd like you to do is to go ahead and try and put it in the calculator like you want to and see what kind of answer you get, and perhaps you'll get the correct answer. I also do have a guide down here at the bottom that tells you how to put it in your calculator as well. Just remember these E's are really that EE button that you have there. And we'll talk about it tomorrow. We'll find out what the answer is tomorrow. So give it a try and bring your answer with you tomorrow. I'll see you then.